All right, we're looking at 9.2, area of triangles, and that starts on page 673. It looks like this. So the real world link is the Biosphere 2 complex in Tucson, Arizona researches Earth and its living systems. Sections of the building are interlocking triangles of the same size. There are two triangles that are outlined in the photo. So looking back at the photo here, they show us these two triangles. And the question's saying they have blank size and the blank shape. So number 2, you're going to draw the figure formed by the two triangles. Go ahead and do 1 through 5 on your own, and when we come back, we'll talk through it. So go ahead and pause the video now and see what you can complete for 1 through 5. Alright, so number 1, it says that the two triangles are outlined in the photo. They have the blank size and the blank shape. They're the same size and the same shape. And I know that because if I see I'm counting across 3 and I'm counting up 3, and right here I'm counting across 3 and down 3, so I know that these are the same size triangles. And so they're the same. We're going to draw the figure formed by the two triangles. So what you see here, it kind of looks to me like it's either a rectangle or a parallelogram, because it's slightly tilted in my opinion. Okay, so this is the form that I'm seeing. Two triangles make up this rectangle or maybe parallelogram. And it says how many small triangles make up the outlined parallelogram. Okay, so apparently they agree that it's a parallelogram. It says how many small triangles make up each outlined triangle. So when we look at this, if you notice, there's a lot of small triangles here. Right? Do you see all those little small triangles? And it's asking how many of the small triangles make up the triangle. Alright, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 triangles make up the outlined triangle. Okay? Describe the relationship between the area of one outlined triangle and the area of the other one. So we're going to be looking at both of them. So let me go back to our picture here. And so we need to look at these triangles as well. And I guess my picture got a little crazy. Alright, so I've got, well, maybe I'll use a different color even. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So they both have 9 small triangles within the outlined triangles. Okay, so describe the relationship between the area of one outlined triangle and the area of the other outlined. They're the same. Yep, same. Draw another parallelogram like the one in the photo. Separate it into two triangles and describe the relationship between the area of one triangle and the parallelogram. So if I were to draw another one, and of course, you know, parallelogram is supposed to have these two are congruent and these two are congruent. And so if I were to go this direction and make two of my rectangles, since this side and this side are the same as this side and this side, that makes up two triangles that are the same. So if I find the area of this one to say, let's say using the example before, be 9, and this one is 9, then the area is 18. Well, what does that say about the relationship between the area of a triangle and a parallelogram? Well, this triangle is 1/2 the area of the parallelogram, or you can say that the parallelogram is 2 times the area of the triangles. So I think that what we're really hinting at is that we want to go with the 1/2 the size of the rectangle or parallelogram. And so the area A of a triangle is 1/2 the product of the base and height. Because if we were to extend this and make this into a parallelogram or rectangle, then you see that these two would be the same size triangles. And so if I found area of a parallelogram, I would use base times height. Well, if I'm finding it for just the triangle side, not the whole parallelogram, then that will be 1/2 of the base times height. So it's just like finding the area of a rectangle and finding the triangle in that. you do area is base times height, and then you divide it by 2 so that you can just represent this side right here. Okay? All right, so it says congruent. Congruent figures, are figures that are the same shape and size. A parallelogram can be formed by two congruent triangles. Since the congruent triangles have the same area, the area of the triangle is 1/2 of the area of the parallelogram. So just going back to the last question that we had, what is the relationship between the area of a triangle and area of a parallelogram? Well, it's the triangle is 1/2 the area of the parallelogram. So the base of the triangle can be any of the sides, and the height is perpendicular. So if I'm saying that this is my base, then I need to find the distance at a 90-degree angle, and that to the very tip, and that's going to be called my height. So if it was, a triangle like this, this would be my 90-degree angle. If it's a triangle like this, this would be my 90-degree angle, okay, to the tip, but at a 90-degree angle with the base. And that's called perpendicular. All right, so find the area of a triangle. By counting, you find the measure of the base is 6 units and the height is 4 units. So we're going to do 1/2 times the base, which is 6, times the height, which is 4. And when I do this, it's completely up to you how you want to go about this. They went ahead and combined the 6 and the 4 and made 24, and then did 1/2 of 24. You could have just as easily done 1/2 of 6 and said, okay, let's take care of this now, and that's going to be 3. 1/2 of 6 is 3 times 4, and either way you're going to get the answer as 12. 1/2 of 24 is 12, or 3 times 4 is 12. Same thing, you could do 1/2 times 4 times 6. I can change the order. It doesn't have to be base times height. It can be height times base, because in multiplication, if it's all multiplication, order doesn't matter. Commutative property says I can change up the order. So here I'm going to cross simplify. I'm going to find 1/2 of 4, which is 2, and then multiply that times 6, and again, I'm getting that 12 units squared. And don't forget, square units. We're talking area, and area means units squared. All right, so here's just another example where it says that you can use mental math to multiply 1/2 times 6 times 4, and you can think of it as 1/2 of 6 is 3, and 3 times 4 is 12. So just like I just got done explaining, you could do the same thing. 1/2 of 4 is 2, 2 times 6 is 12. So it depends on what order you want to put it in. So it says find the area of the triangle, and it gives us this distance is 12.1, and the distance at a perpendicular angle all the way to the tip is 6.4 meters. And so we're going to do base times height divided by 2, or I'm sorry, I like to say it like that, but this is, let's go with what the book is showing, 1/2 of base times height. So again, the book went ahead and multiplied these two together to get 77.44. You could have just as easily have found 1/2 of 6.4, which is 3.2, and then done 3.2 times 12.1. It's really completely up to you on which way you want to do this. So when they're saying 1/2 of, sorry about my doorbell, 1/2 of 77.44, you can take 77.44 and divide it by 2, because we know that half of anything is divided by 2. All right, now I'm going to have you do A and B on your own, and when you come back, I'll have the answers for you. Pause the video now. And if you haven't paused already, or if you're just coming back, remember the OSS, original, substitute, solution. Okay? So remember your OSS, original, substitute, solution, because we want to get used to using the formula every single time and then substituting in what we know. So you can pause now. I'll be right back with the answers. All right, and here are your answers. For A, it should be 9 units squared, and for B, it should be 31.5 feet squared. The way that I went about this was for A, I took care of cross simplifying and getting rid of the 1/2 first, and then had 3 times 3, because 1/2 of 6 is 3. For B, there wasn't an even number in my options here, or I would have done that. Instead, I went ahead and multiplied 9 times 7, which is 63, and then I took 1/2 of 63, which is 31.5. And don't forget your unit squared, your feet squared. So finding the missing dimensions, again, this is a really good reason why we use OSS, the original, then substitute, and then solve, because in this case, we have two different parts, and we're left with a variable. And so having that variable there is important. So what we have is, find the missing dimension of the triangle. We have area equals base times height divided by 2. Notice that they're using divide by 2 all of a sudden, because it means the same thing. 1/2 times b times h is the same as taking b times h and dividing it by 2. For example, that's what I did here. I took b times h, and then I divided it by 2. And I got my 63 divided by 2 is 31.5. As well as over here, I chose to use my 1/2 times 6 and take care of it right there from the start. So using this formula, area equals base times height divided by 2, that's really the one I prefer, but it doesn't matter either way. I want you to be able to be comfortable with either way this is going to go. All right, so, and if one of your sides is even, you can leave it as 1/2. It's really not a big deal. I'll show it to you both ways. So the book shows you area equals base times height divided by 2, and you substitute in what you know. We know that the height is 6, and the area is 24. And so our new expression, or our new equation, is b times 6 divided by 2. And they're doing a multi-step equation, saying, okay, let's multiply both sides by 2 to get rid of the 2 and get the b by itself. But honestly, you can do 6 divided by 2. And that's what I would prefer to do. I would go ahead and take care of 6 divided by 2 right now. This is going to be 3/1. And then rewrite it, 24 equals b times 3. And then divide both sides by 3, and I get b equal to 8. And so that's 8 centimeters. And hopefully, if this is a drawing that's not Mrs. Eccles, you can tell that this is longer than this side, so 8 centimeters makes sense. And you can always check your work, and you know that's a good idea. You can say, okay, let's do base times height. 6 times 8 equals 48. Then divide by 2, because we're talking about just a triangle, not the whole thing. And to find the area of this, it was 48 divided by 2 is 24. Check mark. So you see how that works? Checking your answer shouldn't take very long if you understand how the process works. All right, so just here's another thing. Just check for reasonableness. Check your work. Replace the base times height and find the area by dividing by 2. All right, so in C and D, you're going to do this. Again, don't forget your OSS. If you want to use area equals base times height divided by 2, you can. Or if you want to use area equals 1/2 times base times height, use that. It's going to be completely up to you. You really should become comfortable with both of them, so maybe use one of each. All right, you can pause the video now, and when you come back, I'll have the answers. All right, and here are my answers for C and D. For C, I have the base is 10 meters. And for D, I have the height is 12 yards. And notice that it's not meters squared or yards squared, because I'm talking about one measurement here, not the area. The area is units squared, but just the height, that measurement, just the base, that measurement, is just regular units. All right, example number 4. The front of a camping tent has the dimensions shown. How much material was used to make the front of the tent? So we're going to use our area. 1/2 times base times height. We have the base is 5 and the height is 3. And when we multiply those together, we get 15, and we do 1/2 of 15, which is 7.5. So the area of the front of the tent is 75 square feet, or sorry, 7.5 square feet, or 7.5 feet squared. 7.5 feet squared. All right, that ends our section. And that's 9.2. I'll see you in school.